Hello everyone. In this video, we are going to look at a new technology that's added in LuBan software. This technology is called string art. It was initially invented by an artist. I looked through the internet. I'm not 100% sure whether it is this person that invented this technique, but it seems that he has produced a number of nice artwork based on the string art. Based on the idea. So you can take a look at his website. The main idea behind this technique is to use fine string lines, many of them, to represent an image. And typically you can represent human face through this method. So for instance, this human face consists of thousands of thin black strings, black threads. And sometimes this method is also called thread art. And the idea is exactly the same. I have added this method to LuBan software. Although the initial idea or the original idea was based on the physical pin that you can wrap around the string, the key behind this idea can be implemented without any limitation to hardware. For instance, we can just use a virtual black line to represent the string, and there is no constraint of having to use these metal pins. So let's go and take a look at the implementation of string art in LuBan. When you open LuBan software, the default window is a 3D window. And in the current version, I have added the string art function in 2D window. So you have to click invoke 2D window. And then go to File, Create, Halftone. Halftone is usually used to refer to a black and white transition of an image. You use black and white pixels or regions to represent an image. We have the halftone function for quite a long time. And I've added two more options, line and circle, to represent a photo. But let's take a look at the existing functions. So for instance, I'll take Tom Cruise, one of his photos, as an example. If you represent this photo in the halftone method, you can use the dot to represent this photo. This is a typical technique that we see in the old newspaper. They use black and white dot to represent a grayscale photo. You can also use, you can also use stripe, which is black and white lines, radially spanned lines, spiral lines. This is a very cool representation. And stencil. In order to use stencil, you have to open a black and white template picture. And a typical template picture consists of black and white stripes, but the stripes can be any shape. For instance, I have two kinds of template in my computer. One is curvy, roughly vertical, but there are some curvy regions. The other template is more curvy than this one, and it has certain triangular pattern. So by loading these templates, you can still see Tom Cruise figure, Tom Cruise face in the representation. The two new methods are called line and circle. Line is the one that shows us the string art. The image that we see here is formed by 3,000 strings. You can choose black and white background or black background. And currently it is in the dark background option, so the lines are white. If you choose bright background, white background, then those lines will be dark. Okay, and this option is the most often seen option on the internet. Usually you see black lines on the white background. If I reduce 3000 lines to 300 lines, you start to see what's going on. The algorithm continuously putting black lines more and more in order to represent the image. We have a fidelity setting. Fidelity setting is related to an internal structure of the algorithm. So the idea behind the algorithm is we randomly choose a set of lines. For instance, indicated by the setting here, I randomly choose 100 lines in the image. And from the 100 lines, I will only use the one that minimizes the error between the white image and the original Tom Cruise image, which maximize the error reduction. After this line is picked, I will draw the line on the image. Then I will move on to another 100 images, so on and so forth. So let me set it back to 3000 lines. It looks pretty much like Tom Cruise face with some distortion. If I reduce 100, fidelity 100 trials to 10, as you can see, the images are not very well. It produces more noise because in this case, each image drawn on the photo is selected from 10 randomly generated lines. As you can imagine, the more random lines that you generate to select from, the better is your final result, because you are very selective. If you select one line from 100, you are very selective. If you select one line from 10 lines, you are not that selective. And then the face has a bigger distortion. And also you can notice the difference between the option bright and dark. Indeed, sometimes I find certain images are better represented when you use the bright option. Other images are better represented using the dark option. For example, this one. Using the dark option, we see a better representation, especially the eyeglasses area. It is much better represented comparing to the other option. When you select bright, you see a lot of spikes. But when you select dark, it's kind of quite smooth when you do a direct comparison with Tom Cruise's original photo. And certainly, if you increase 3000 to 5000, you will have a better representation. It becomes brighter because the lines are brighter, and we have 5000 lines. In this case, you can change the line width. Line width indicates, in real world, how thick is your line. The thicker your line is, the lower resolution is your final representation. So ideally, when the artist initially designed this method, he used very thin lines. When you see the image too bright, you can reduce the thickness of the line to 0.05 pixel per line, and that gives you a slightly better representation. Similarly, when you go for bright, it is also better. In the current implementation, I have put an upper limit, 20,000. When I choose 20,000, this is very dark, so I'm going to reduce it to 0.01 in order to get a better image. Not very good. So that's the best we can get for the bright background. If we want to do for dark background, this one is really good. It's really good already, but it's 20,000 images. So by now I have presented the basic principle behind the string art idea, as well as one example. You will see that the same principle can be implemented not on the lines, but on circles as well. So I've chosen the circle representation, and you see a lot of circles. It's not very visible, so let me change it to 0.1 line width. Maybe increase a little bit more. Tom Cruise face start to show up, and its face is represented in this case by many circles. The idea is the same. We select one circle from 10 randomly generated candidates. If I change 10 to 100, the representation will be a little bit more accurate. The fidelity will be a bit higher. Many circles move to the background because we are in this option we have the dark background. The original image shows a white one, so a lot of the effort of the circle goes to the background to try to make it brighter. Maybe I'll increase, see whether this. Oh, Tom Cruise face still shows up by a little. Some circles still go to the face. It's just not that visible. If we change 2000 to 5000, we will have a little bit better representation. And that's the representation in the dark mode. If you choose the bright mode, so to be honest, I think the circle representation in this photo is better than the line representation. It looks really good, really close to the original photo. And when you save, let me switch back to lines and reduce the line width. When you save the image, save, delete this one, and save photo, you will get a folder. Wait, where is the folder? Save, desktop, save folder. In this folder, you'll have DXF output, SVG output. These are the two files you can feed to laser cutter. SHP is native to LuBan. And let's open the SVG and SHP. It looks really dark. That is because the line width in this image is set to a fixed value. But as you can see, there are many lines. You can input the SVG file to your laser cutter and then select by trial and error an appropriate engraving laser power. So on a laser cutter machine, you can probably represent the effect that we have. On laser cutter, typically the burn marks by the laser is dark. It's a dark line. So the dark background, bright line is not exactly suitable for laser cutting technology. Often you have to see the preview of the results by this option, the bright option. The method is not only useful for a real application in laser cutting, in threading, but also useful for 3D printing. And there is a person on the internet that has produced amazing STL maker, this kind of, some name like this, amazing STL. Let me just quickly go to his website, amazing STL generator, and you can find his work. It's a decent software that can generate this kind of nice string representations. If you are interested, search the keywords and you'll find his software. I could implement this in LuBan as a 3D printing option. I didn't do it because I have tried many images, and to be honest, it is a pain to look for good image that is suitable for this type of technique. In my opinion, if I just randomly find an image, it will not be represented very well, even when we use 5,000 lines. So I don't even know what's the original image look like. Let's click the bright background and see, oh, okay, it's a deer. It's a deer. The original image is a deer. That's the representation, okay? And I have many other examples loaded. Deer, the eyes, I have found that if you try to represent a SketchUp image, then the results are pretty good. This is the eye image. And I can reduce it even to 2,000 lines to have a nice representation. Because of that, I have tried many different. So for American flags, it works really bad. It doesn't give you a nice representation. Okay, and for Reagan, the facial image, sometimes it works, sometimes it doesn't work. So, and for the facial image, if you don't use more than 5,000 lines, sometimes you get nothing. Only when you increase the lines substantially can you see something in this image. So you get what I mean. For various kind of images through my test, I don't think this method is strongly suitable for converting any kinds of image. Therefore, I did not, for now, I did not move it to our 3D printing 3D window. Because I hope when I add some useful functions to the suite, to LuBan suite, it should work just like snapping the finger. However, this method doesn't work like that. It requires a very careful selection of certain sort of photos. And exactly what kind of photos, I don't have confidence to tell you. I have to do trial and error in order to find a very nice photo for this method. So for now, this method is only prepared for our laser cutter users, because for laser cutting, you can generate very fine laser engraving lines. By tuning the power, the line width that you engrave on a piece of metal or wooden sheet can be adjusted. If the power is strong, the line width is strong. If the power is weak, the line width will be weak. So you have a variety of control range to tune your final results. But for 3D printing, maybe not at this stage. In our next release, I have prepared our 3D printer users something else to play with. Thank you very much for your attention. Before we finish, let's get a better look of Reagan. Maybe we increase this to 10,000. Would this be very nice? Let's wait and see. Yeah, it's better. This is a better image of Reagan. The original image, it looks like this. And what we can get after 10,000 lines gives us this sort of image. It's not bad for the string art. That is all for today. Thank you for your attention.